parts. You notice it comes in, it goes around, goes out. Whether you connect them or don't connect them is important. Okay. What is relative to say is you will never buy a new compressor with these oil cooler pipes, but there are still a number of oil coolers pipe systems in the field. You will still have them. They still come out, right? So now let's look at how we connect up our oil cooler pipes. It's supposed to come here, and now normally you would take it off here or there. In other words, very close to the heat of your condenser. It should have come off here, but for display purposes, the thing was built about 20 years ago. For display purposes, I want it nice and neat, and I took it off in the wrong place. So here we've cooled down the gas. Now we take our cooler gas down, and we take it around there all nice and pretty, and we take it around into our oil cooler pipes. It then comes out of our oil cooler pipes and it goes back into the circuit. So what you're doing here is you're heating up your oil just a little bit in the beginning, but when you are running down, you're actually cooling your oil down. So it does two things: prevent liquid giving your compressor oil. Old technology. The new technology is a double door thermostat. You get there, you'll find out. You don't use it. When you replace a compressor that had oil cooler pipes and now you've got a compressor without oil cooler pipes, you don't sacrifice that portion of the condenser. Here you see the two pipes coming off. You make a U and you connect it. Here's the compressor for you. Here's the piston. It goes up and down. Okay, here's the conrod. Here's your flywheel, your crankshaft. Okay. As this crankshaft turns, okay, so if you've got it attached here, as it comes here, it'll be up. As it goes down, and then it goes up again. So this piston is busy doing this all the time. Okay, the motor drives this. On a car, you've got explosions happening there, which is driving this, which drives the wheels. But it's the same concept, it's just different. Okay, right. So the motor turns this, and the piston goes up and down, up and down, up and down. You see that, eh?
Yes, sir.
Right. Now, there's the piston. Okay, hold that for you. Okay. There is the chamber, like that.
Okay.
This piston goes in there, and it goes up and down.
Okay.
Okay. Now, if you look in there, and you look good, you'll see a plate.
Yes, sir.
Okay. You're looking here, and you're seeing that plate.
Yes.
If you've got really good eyes, you might see that hole. That plate you see here is what we call the valve. If it was an air compressor or a bigger compressor, they sometimes refer to it as a reed valve. Okay, now, when the piston goes down, because the plate is on this side, okay, it sucks the gas in. Okay, when the piston starts going up, it pushes this plate close against that hole, which means the gas can't go back. Can't go back.
Okay.
Okay, but this plate is on the other side of the valve.
Okay.
Okay, which means that when it goes up, the gas goes out here to the high side.
Okay.
Okay, so when it's here, there's no more gas here. Okay, no more gas moving. Now the piston starts going down. This valve is pushed close, but this valve is then drawn now open because the pressure is now that way. Okay, so what it's doing is taking gas here and pushing it there. Here and pushing it there. Okay, that's how compressor works. Okay, now the valve plates is just what we call a valve plate. If you look at it, it's a little thin plate.
Yeah.
Easy to break, or easy to bend. You can bend the valve plate, anyone, this one or this one. Okay, all you got to do is let's say run the compressor hot, soupy for example, and the compressor starts getting too hot, it boils the oil, and the oil gets black, carbonizes, and all you got to need is a grain of carbon in there, and it will no longer seal. The gas will go like this, up and down, through, and not go out. But they call it an inefficient compressor. Okay, or if you've got a block and you run your compressor and you're hammering against this head all the time, okay, you're going to bend that valve and you're going to break that valve.
Okay.
As soon as you break one of those valves or bend one of those valves, it becomes inefficient or just doesn't pump. Yeah. Or you break the conduit.
Okay.
Very easy. Yeah, just very pump against the head. On the modern fridges, what actually happens on the modern fridges, that middle box there, that's a box of about, I don't know, it was in the field for about 8 years or so. On the modern fridges, they pump out all the oil. Explain to you, just okay. But they pump out the oil because this thing has to run in oil. There's no bearing here. This is metal on metal. Provided the oil is doing its job, it will run for 100 years. But the oil is not there or not doing its job because the oil is supposed to go with the gas and come back with the gas. So this thing will always be running in oil, in like an oil mist, lubricating all the time. Okay, if your oil doesn't return, okay, oil is going to become less and less here, and this thing is going to back up. It's going to seize. Metal on metal, it's not going to last long. The modern fridges, almost always, the compressors are seized. Seized, metal on metal, can't turn up and down. Okay, so there's lots of things you can do to screw a compressor. Here is compressor. Okay, this, we discussed the valve. Here's the compressor. There's the motor, and there is the compressor side of it. Okay, it's got, this is a very, very old compressor. This is about 60 years old, this compressor here. Okay, the air will come in, there you have your valve plate there. Okay, it's domestic. Okay, that takes me a week to bring you up to speed on domestic refrigeration. Okay, here is our domestic unit. This is what is on any household fridge. This is your compressor. Okay, we're going to explain, we're going to teach you about the compressor. This is the unit that goes on the back of the fridge. We call this a condenser. Okay, we will go through it. This is the inside cold plate. What we call, the correct name is evaporator. It's called a cold plate. It's the item that gets cold inside, generates your heat. We'll be going through this. Your second week is going to be commercial. Okay, here is a commercial unit. Okay, these commercial units is what you see in all the supermarkets, in all the factories, the bigger units. It's fridges, the freezers, the wall freezers, all of that. That is all commercial refrigeration. Similar system, but different concepts. Okay, here's the compressor. This one is a very, very old compressor, but these used to be the king of the compressors in the day. Okay, here again is the condenser. Okay, here we have a receiver tank. Here's the dryer, and over here is the evaporator. It's normally got a fan here that will draw your cold away. Here we teach you how to pump down, how to gas up, how to repair, how not to waste gas, how to do things properly. All the students want to do air conditioning. That being said, air conditioning module is right at the end of the commercial. And it's just an entertaining talk because you know already what it is. Just telling you the ins and outs and the bewares and all the rest of it. Once you've done the commercial, you can do virtually anything. Back to our courses, refrigeration school. The first week, domestic. Second week, commercial. You can do the domestic course without doing the commercial. You can actually make a good living doing domestic fridges. You can make a good income any which way you want doing domestic fridges. But either one of these courses, you need the tools, etc., to do it. We prefer that you bring your own tools. Okay? It makes no sense to do a refrigeration school training course and not have the tools and not have the ability to go out and start earning money, start fixing fridges. If you can't afford it, because believe me, tools are expensive. Okay? If you can't afford it, we will hire you tools out. If you want to come on the course and get tools later, also not a problem. You can get them hired out to you.